All right, let's finish out this packet. So question 55 is asking us about the position of a body moving on a coordinate line given by some position function, and when does the body change direction? So the body changes direction when the derivative changes sign. When v of t changes sign. So get v of t to t minus 7, set it equal to 0. Check the signs to the left and the right. So when t is less than 3.5, the velocity is negative, and when t is greater than 3.5, the velocity is positive. That means it changes sign at 3.5. Therefore, the answer is choice B. Now, in question 56, they are claiming that the answer is 36. Okay, that would be the position. In this question, they're giving you a position function, right? And they're asking you for the distance. So picture it this way. Let's say you walk forward 2 feet, and then you walk backward 2 feet in the opposite direction. Your displacement 0, right? Your position is 0 because you're where you started. However, your distance is 4. So in this problem, okay, the answer is not amongst the choices, because what you need to do first is you need to get the derivative. So I get 3t squared minus 30t plus 48. Take out my GCF. T squared minus 10t plus 16. Factor minus 8 minus 2. So you get 8 and 2. Making a little sign chart. 0, 2, 8. So when I substitute this in, if I substitute in, say, 1 into the function, and I'm looking at the velocity, right? So if I sub in 1, I'm going to substitute in here. I'm going to get 1 minus 10, that's negative 9 plus 16, whatever, it's positive. Let's say I substitute in 3. I would get 9 minus 30 plus 16. Well, that's negative. If I substitute in 9, for instance, I would get, I'll just do 10, make my life easy. 100 minus 100 plus 16, that's positive. So here's the thing. When the velocity is negative, it's moving to the left. So when they're asking you for the distance, you actually have to integrate, okay, the absolute value of the velocity. We won't be learning that until later in the year. But here's the thing. You can see that the sign of the velocity changes at 2. And from 2 to 8, it's negative. So when they're asking you to find this distance from 0 to 3, you would have to do s of 2 minus s of 0 plus, okay, the opposite of s of 3 minus s of 2. So just think about that. I'm not going to belabor this point because the answer is not amongst the choices. I don't know what happened here. Somebody dropped the ball. That's okay. I drop it often too. We all do. Take a look at number 57. At time t is greater than or equal to 0, the velocity, okay, they give you the velocity function. When is it moving backward? Well, it would be moving backward, obviously, when the velocity is negative. So factor this. T minus 8 times t minus 1. T equals 8. T equals 1. Make a little sign chart. 0, 1, 8. So the velocity is positive here. because it's negative times negative. And then over between 1 and 8, the velocity is negative because it's negative times positive. So when they're asking us when is it moving backward, that would be choice A. Taking a look at number 58. So for number 58, they give you this graph. So pretty, right? They want to know when does the body reverse direction. So the body would reverse direction where the velocity changes sign. It only changes sign at choice A. So in number 59, they're asking us, what's the greatest velocity? Well, this is the graph of the velocity, guys. So the greatest velocity is obviously just going to be 5. Don't even know why they bothered us with this question. Maybe they wanted us to think about EVT. Since it's a continuous function, there has to be an absolute max. Not quite sure where they were going with that one. Let me move down to the next page. Page 13, we already did number 60. It was the same as number 27. Skip that. Okay, so apparently you guys did not get to related rates. Here's how related rates works. You're given a point in time, okay? You're given two functions that are related in the problem. You do implicit differentiation by getting their derivatives with respect to time. And then that gives you rates that are related, and you substitute in your information. So like the first problem, they're talking about area. So we have of a circle. So we have area equals pi r squared. Now I get these derivatives with respect to time. dA dt, 2 pi r, dr dt. So I have these rates related, don't I? So now I'm going to substitute them in my information. Well, it says the area is expanding at a rate of 6. That's dA dt. 2 pi, it says when the radius is 109. They want dr dt, so just divide 6 pi by what I just circled, and you end up with choice B. That's it. That's all there is to it. Don't overthink related rates. You will drive yourself crazy. No reason for that. Number 62, I'm going to show the work down below here, okay? So you have a piece of land that's shaped like a right triangle. They tell you that two people start at the right angle. Hello, let's start over here. And they walk the same speed but along different legs. So this guy goes this way, this gal goes this way, or it goes this way and it goes that way. It doesn't matter, whatever. So the area formed by the positions is changing at a rate of 4. Okay, what does it say? 4 meters squared per second. So that's dA dt. So dA dt is 4. Then it says, how fast are the people moving when, okay, they are 5 meters from the right angle? Well, here's the thing, guys. If I called this x, right, and I called this y, they told us in the problem that these rates are equal. So if I want to come up with a formula relating the area to this, I get area equals x times y divided by 2. Okay, I could multiply both sides by 2. It really doesn't matter. 2 times a is x times y. Now let me get these derivatives. 2 dA dt, the derivative of the first times the second, plus the first times the derivative of the second. But these are equal. Keep that in mind. dx dt and dy dt are equal, guys. So why don't I just call them both something? Let's just call them both k. So I have 2 dA dt is, I'll factor it out, k times y plus x. But they're telling us in the problem that the people are 5 meters from the right angle. So this is 5, this is 5. And they're also telling us that dA dt is 4. Okay, from there it should be smooth sailing for you. Solve for k. You're going to get 0.8. Right? And that's your answer, choice D. I don't really think, I mean, these are math problems, but I think of them more, honestly, as reading problems. Number 63, water is being drained from a container, which has a shape of an inverted, right cone, circular cone. The container has a radius of 4, so at the beginning it has a radius of 4, when the height is 8. Then it says, at the instant, so this is about related rates. You have at the instant. When the water in the container is 5 inches deep, well, we have similar triangles here, guys. So when the water is 5 inches deep, we have this triangle down here, which is similar to this triangle up here, because we have these angles are congruent and the right angles are congruent, so they're similar by angle. So we start off with the original ratio, which is 4 to 8, right? Or I could say 8 to 4, it doesn't matter. So I'm going to call this distance y and this r. So that relates to y over r because we have similar triangles. Solving that, I get that r equals y over 2. So now I have an equation relating r to y. Y is the height. I have the volume. Volume is 1/3 pi r squared y. So I can take the y over 2 and substitute it in for the r, because I want to relate the volume to the height, because they're giving you the surface level is falling at a rate of 1.2. So that's the height. And they're asking us to find the rate at which water is being drained. So that's dV dt. Multiply all this out. You end up with pi over 12 times y cubed. Now get dV dt is 3 times pi over 12 y squared times dy dt. I'm going to substitute in my information, so I substitute in 3 times pi over 12 times 5 squared times 1.2. And just do that math. That's your dV dt. So these are, I know these seem extraordinary to you since you didn't get to related rates, but these are really typical related rates problems. The related rates problems that are normally done in 11 honors are much, much worse than the problems that could be on the AP Calculus BC exam, because they really don't have time, to wait for you to work out these problems. So whatever related rates would ever possibly be on the AP exam would not be time consuming. So in the next question, they give you these graphs, right, of some function p, and then they give you the graph of its derivative. They ask you to select a possible graph of f that passes through the point P. So it says, oh, this is the first derivative. So this is the first derivative, this is the second derivative. So if you look at the first derivative, you start off, the function, you see here, the derivative is positive, so the function starts off as increasing. That means you can automatically get rid of B, C, and D. Well, the answer is A. Well, so we're done. Okay? If you're interested, obviously here the function would be decreasing, still decreasing, increasing. But here the function would be concave down because the second derivative is negative, and here it would be concave up. So feel free to experiment with that more. And guys and girls, that's it. that's a wrap. Thank you.